To find the side lengths of a triangle that's given to you on the coordinate plane, specifically a right triangle. So there are two ways that we can measure on the coordinate plane. We can either measure horizontally along our x-axis or vertically along our y-axis, but we can't measure diagonally. So we can easily find the two legs of our right triangle. These two sides are going to be our legs, but we can't find the hypotenuse in the same way. So just in case you are unfamiliar, right, the distance across one of the units is not the same as the distance up or down. So we know that if we were to count how long something is, we could just count in bunny hops, right? We can count 1 unit, 2 units, 3 units, 4 units, and so on. But the distance across the units this way is not the same, okay? This is not equivalent to 1 unit, 2 units, 3 units. That's not the same. So let's go ahead and just get the measures of our legs. So our legs we're always going to call A and B, and it doesn't matter which one you call A and which one you call B, but you do find the lengths of A and B the same way, just using our bunny hops. So side A is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And I always use bunny hops because some people will measure like the tick marks, but that is not a good way to go because you're going to mess up that way. Side B, let's measure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we have A being 9 units long and B is 11 units long. Those are the two legs of our triangle. So this is a leg and this is a leg. So remember that the side lengths are always opposite the angles. So if side A is at the bottom, then angle A will be at the top. Okay, if side B is on the right, angle B will be on the left. And we always, always, always call our hypotenuse C. Okay, so that would make this angle C down here. All right, so now we have our triangle correctly labeled. We have our angles labeled, our sides labeled. We just need to find the length of C. So we have the length of A and B just by counting our bunny hops on our coordinate plane. But angle C, we have to use our Pythagorean theorem. So the Pythagorean theorem, as you should know, is this: A squared plus B squared equals C squared. Okay, and C is always the hypotenuse. We always call our hypotenuse C, and hypotenuse is, first of all, it's the longest side of a right triangle. It's also the side opposite of our 90-degree angle in a right triangle. So those are the two characteristics that it has. So now we can just substitute in what we know. So we know side length A is 9, so 9 squared, plus B squared, well, B is 11, so that'll be 11 squared is equal to C squared. So 9 squared is 81, plus 11 squared, I think that's 122. Let me put that in my calculator. So I'm just going to put in 11 times 11 because that's the same thing as 11 squared. So 121 is equal to C squared. Then I can do 81 plus 121, and I would get 202 is equal to C squared. So now the inverse operation of squaring a number is taking the square root of that number. So in order to solve for C, we would need to take the square root of both sides of our equation. Squaring a square cancels out. They are inverse operations. So now we just have the square root of 202 is equal to C. Well, what's the square root of 202? So you can just leave that as the square root of 202. That's perfectly fine. It's not a perfect square, so it doesn't really simplify to a nice number. But because these are side lengths and we really want to know how they relate to each other, I think it's best if you go ahead and put that in your calculator. So you're going to get a weird number, and most of the time you are. It's very rare that you're going to get a hypotenuse that is an integer. There are some special triangles that always have nice integer legs and hypotenuses, but those are very rare. So when I put the square root of 202 in my calculator, I get approximately 14.2 21, approximately, units. Okay, so now we know that side length C is about 14 units, right? And we can see that since this is 9 and this is 11, 14 is the longest size, so that makes sense. Okay, and we can also, as long as it's longer than both of your legs, then you know that you're good on that end. And then kind of use your judgment to tell, like, is it too far off, right? So use your process of estimation. So that is how you find the lengths of all of the sides of your triangle on the coordinate